Hello and welcome to the next video. Here we're going to be carrying on what we've been doing on drawing quadratics. Okay, so here we have a quadratic equation. Okay, x squared minus 8x plus 12. Okay, and everything we've done so far would allow us to draw this. Okay, we'd be able to work out the roots and the turning point and draw it. Okay, now there are two ways we could do all these things we need from it. And both of those mean we need to factorize this. Okay, so if we factorize this into two brackets, we'd be looking for two numbers that times together to make this last number and add together to make this. Okay, we go through all the steps, but our two numbers that times together to make 12 and add together to make minus 8 will be negative 6 and negative 2. Okay, so that would give us x negative 6, x negative 2. And from what we've done before now, we know that the roots of this equation then, where it crossed the x-axis, would be at x equals 6 and x equals 2. Okay, so if we had a little sketch of it, we know it's going to cross the x-axis here at 2 and it would cross here at 6. And we know that the turning point has to be in the middle of these because it's symmetrical. So the turning point would be at 4 here in the middle. Okay, and then we could substitute in what x equals 4 would be into here. That would give us a y value, and then it would give us a y value of negative 4 if we did that, which would be down here. Okay, and then we could go through and we could draw that graph. Okay, but we only know that because we factorized it into this form. Okay, we could factorize it into another form. We could look at completing the square of it. Okay, and if we're going to complete the square, that means we'll end up with brackets like this and then some number at the end. So in here we put x, and then remember we put half of this, so negative 4. And then what we do is take away whatever the half of this is squared. So we'll take away 4 squared, which would be 16, but we've still got this plus 12, and this would give us y equals x minus 4 all squared minus 4. And this is what we were just looking at in the last video. Well, this is going to tell us the turning point of this is at 4, negative 4. And we could substitute in x equals 0 to get the y-intercept. If we did that, if we substituted in 0 here, we get minus 4 squared is 16. Take away 4 is going to give us 12. So we do a little sketch. And we know, okay, turning point is at 4 minus 4 down here. And it's going to cross at 12 up there. So it's going to look like this. Okay. And you see that then these are the same graph, okay? Because this is at 4 minus 4. This is at 4 minus 4. Okay? And these are the same graph, okay? But factorizing this differently told us different things about it, okay? But each of the ways told us enough to draw the graph accurately, okay? But we could only do that because this formula up here could be factorized, okay? But we're not always going to get a quadratic that can be factorized, okay? And that's why we need to know about something called the quadratic formula, okay? A way to plot graphs and find out roots and things like that if you can't factorize the graph, okay? Sorry, if you can't factorize the equation. So let's look at an equation then that we can't factorize. Okay, so let's look at this equation here. 2x squared plus 4x plus 1 equals 0. Now it's still a quadratic, still got the 3 terms, still starts with an x squared, okay? But we can't complete the square for that. We can't factorize it into the two brackets either. We can't think of two numbers that times together to make 1, but add together to make 4, okay? Even with a 2 involved. So we need to use something else, okay? What we need to use is what we call the quadratic formula, okay? Now, I'll warn you before I write it down, quadratic formula looks pretty bad, but is very simple to use, okay? So don't get scared off by what it looks like. You are given it as well, so you don't need to remember it, okay? But it's much easier to use than it would first appear, okay? So the quadratic formula tells us that for any equation we have that is in this form, ax squared plus bx plus c equals 0. Okay, so for any equation that's in that form, we can use this to work out the roots of it, okay? We can say that root x equals negative b plus or minus, now this is new to us and we will come to what this means, okay, the square root of b squared minus 4ac, and all of that divided by 2a, okay? And then the b value, well, that's there. This example would be 4. The a, this example would be 2. The c, in this example would be 1, okay? And the plus or minus means we want to do this equation once where we add this bit in and get an answer, and then we do it again where we take away this bit and get an answer, and that gives us 2 roots. And normally we expect these equations to have 2 roots. Because of the shape of it, it's going to cross the x-axis in 2 places quite often, okay? Now, before we get on and start using this equation, we're just going to talk about it a little bit, okay? Now, this bit of it here, inside the square root, the b squared minus 4ac, okay? This has a special name, okay? So this part of it, b squared minus 4ac, that's known as the discriminant, okay? I've just realised I'm not at all going to fit that in there. Discriminant. Okay, I know that's a bit difficult to read, but it's spelled D-I-S-C-R-I-M-I-N-A-N-T, okay, for discriminant. Now, this bit of the equation, this discriminant, is really important, okay, because this can tell us some important information about the graph before we even go ahead and do the whole formula. Okay, so there are some rules to remember about the discriminant, okay? And they are, if this discriminant, so I'm going to put a line down here to keep this separate and to remember it's important. So if you work out just this bit of it, if that is greater than 0, okay, what that means is the roots exist and are distinct. So that means they're different from each other, okay? So basically what that means is this graph does cross the x-axis, and it does it in 2 places because the roots are distinct from each other. They're different, okay? Now, if the discriminant is equal to 0 when you work it out, what that means is the parabola, remember that's what we call these types of graphs, the parabola, the turning point of it touches the x-axis, okay? Parabola touches x-axis, okay? So basically what that means is there's only one root, because it's only touching the x-axis in one place, so the little smile, the bottom of a smile, or the top of a sad face is on the x-axis, okay? And then the last bit, as you can probably guess, is if the discriminant is less than 0, what that tells us is then there are no roots. So what this means is it doesn't cross the x-axis at all. So either it's a smiley face one, where its turning point is above the x-axis, so it never touches it, or it's a sad face one, where the turning point is below the x-axis, so it never crosses it. Okay? And this gives you some clues about what your graph is going to look like. Okay, so if you work out your discriminant first and you get an answer bigger than 0, well then you know to be expecting 2 different values for roots. Okay, if you work out this and you get exactly equal to 0, well then you know you'll just get 1 value for where it's touching the x-axis. Okay, and that can be used as a little step to tell you a bit more about the graph. Okay, and then it makes the later on use of this equation easier as well, because you'll already have worked out the discriminant. Right, so let's look at this example then and actually find the roots of this equation. Okay, so we might not even necessarily need to draw something like this. Okay, it might just say solve the equation, okay, or find the roots of the equation. Okay, so you don't even need to always draw these, especially because quite often your answers might have decimal places in. Okay, and that's a pain to draw. Okay, so we'll do this one and then we'll talk about how you know whether you need to use this equation or not, or whether you can solve it the old way we've done before. Okay, so we're going to be looking at 2x squared plus 4x plus 1 equals 0. Okay, now your first step, once you've worked out that you need to use your quadratic formula, the first thing you want to do is work out the discriminant. Okay, so for step 1, can we see that? Just about, just move it over a touch. Step 1 is to work out the discriminant, and that's this bit, b squared minus 4ac. So let's work that out then, and we'll sub in our values. Okay, remember, this is a, this is b, and this is c. Okay, so b squared, well that's going to be 16. Take away, and we'll put this in brackets just so we know it's all times by each other. Take away 4 times 2 times 1. So that's 16 take away 4 times 2 is 8 times 1 is 8. 16 take away 8. So that means our discriminant is equal to 8. And if we look back up here, that's greater than 0, so that means the roots exist and they are distinct from each other. So there are 2 separate roots to use here. Okay, so that's the first step worked out. Now let's go and work out what the roots are. Okay, so we've worked out the discriminant. Let's work out the roots. Let's solve the equation. Okay, and so to do that, what we do is just pop everything in to this equation. Okay, but we're expecting 2 answers, remember. Okay, so we need to do this twice to get those 2 answers. Okay, the first time we'll do it where we add this bit, and then we'll do it again where we take away this bit. Okay, so the first one I'm just going to write up here where we add, and then where we do it when we I'll do take away underneath. Okay, so first we're doing it where we're adding them, so that means we're going to have x equals negative b add the square root of b squared minus 4ac all over 2a. So that means negative b, okay, well that's 4, so negative 4 add the square root of this, but we've already worked out this bit is 8, so plus the square root of 8 divided by 2a, so that's negative 4. Square root of 8 will pop on our calculators because it's not a nice one. Okay, so the square root of 8, lost the square root button, 1 second, is 2.83 if we do to 2 decimal places. Okay, and then we're going to divide that by 2 times a, which is that 2 times 1 is 2. This gives us, then again, you can pop it onto your calculator if you want. So we've got negative 4 plus 2.83, and then we divide that by 2. That gives us negative 0.5 9 to 2 decimal places, okay? So that's one of the solutions to this equation. Oh, sorry. I'll pull that up, okay? That's one of the solutions, okay? We have to do it again now, where instead of adding the discriminant here, we take it away, okay? I'll try and squeeze this in. I haven't really left myself enough space, unfortunately. Actually, let's do it down here. It's going to look a little bit messy. I'll leave a bit more space on the next one, okay? So, that was when we were adding them. This time we're going to be taking them away. So, if we're taking them away, our formula is going to be x equals negative b, take away the square root of b squared minus 4ac divided by 2a. Again, we're subbing everything in. All the numbers we're subbing in will be exactly the same. The only thing that's changed is this is now a negative rather than being a plus. So we've got negative 4 take away the square root of 8 divided by 2, which is then negative 4 take away 2.83 divided by 2, which is going to give us negative 4 take away 2.83 divided by 2 gives us an answer of minus 0.71. Again, to 2 decimal places, okay? And there, that is us solved the equation, okay? And the way we'd write this as a final answer would be x equals either negative 0.59 and negative 0.71. Okay, and there we have solved that equation. Now, I know that working is messy. I'm going to do another example where it's hopefully neater. Okay, I know the equation looks horrendous, but the actual maths involved was really easy. Okay, it was just subbing numbers in. Okay, so let's look at another example of this then. Sorry, this is a longer video, but it is a really important equation to practice. Okay, so now let's look at this question, okay? Solve the equation, given your answer to 1 decimal place. That is a big clue, but you need to use that formula we've just learnt, okay? If it asks you to solve it in decimal places, it means you won't be able to factorize it, and you need to use that equation, okay? So, this is what it wants us to solve. X squared plus 5x minus 2 equals 0. So, let's start by writing down what our quadratic formula is, okay? Again, you are given this, so you don't need to remember it yourself. Okay, so it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the next step I'd recommend you always do is write down which of these numbers is a, b and c. Okay, so a is what's on your x squared, b is what's on your x, and c is the number by itself. Okay, so here a is 1, b is 5, and c is negative 2. Okay, right, so first step is to work out the discriminant. Okay, so our first step, yep, can be seen there. First step is to work out the b squared minus 4ac. So let's do that then. B is 5, so we've got 5 squared, and I'm going to take away 4 times 1 times negative 2. So 5 squared is 25, take away 4 times 1 is 4, times negative 2 is negative 8, so 25 take away negative 8, they become a plus. So equals 33. Okay, so straight away, that's telling me something. Remember, if the discriminant is bigger than 0, it's telling me I've got 2 real roots that do exist, so it definitely crosses the x-axis, and they are different from each other. Okay, so next step is to solve. Okay, and remember we need to solve it twice. We need to solve it once where we add this bit on, and then once where we take that bit away. So we'll do the adding one, and then we'll do the taking away one. They should each give us different answers, and then those two answers are the solutions. So let's look at the adding one first. That's going to tell us x equals negative b, so it's negative 5 plus the square root of 33, because we've already worked that out. And we're going to divide it by 2 times a, so 2 times 1 is 2. So that's negative 5 plus, let's pop this into our calculators, the square root of 33 is, and remember it said to 1 decimal place, so let's stick with that, 5.7 divided by 2, and then in your calculators again, making sure you work out the total to this top line first, and then you divide it by 2. So negative 5 plus 5.7, then we'll divide that by 2, gives us 0.35, but it only wants it to 1 decimal place, so x equals 0.4. That's one of our solutions. Now we'll look at the other one where we take away instead. So now I've got x equals negative 5 take away the square root of 33. Remember, none of the numbers I'm subbing in here are changing. This is all that's changing, the plus and the minus. Divided by 2. So we already know, well, that's going to be negative 5 take away 5.7 divided by 2. So that means x equals, so I've got negative 5 take away 5.7, divide that by 2. It's going to give me negative 5.35, and again we want 1 decimal place, so equals negative 5.4. Okay, you've got your two solutions, you've solved it, but then just to be extra careful, to make it really clear, we'll write down at the bottom here then x equals 0.4 and negative 5.4. And that's us solved that equation to 1 decimal place. Okay, so I know, again, formula looks horrible, absolutely fine to use, you don't need to memorize it, just sub in your numbers, okay? Hopefully you understood that. If not, you know how to get in touch with me. Thanks for listening and goodbye.